Good day, good people. In today's lesson, we are going to look at types of vectors. Saka toda the different types of vectors. This is going to be our subtopic. What are these types of vectors? So kana tichitarisa types of vectors, we are primarily going to consider what are called position vectors. Then tichabva taita build upon position vectors kuti understand anonzi displacement vectors. That is going to be the central thesis in today's lesson. So let us start with position vectors. Saka tichanyora maword definitions to define what position vectors are. Then we are going to reinterpret mathematically. So when we look at position vectors, what exactly are we considering? Tirikuti a position vector always, and I want you to underline the term always, originates from the origin. And we are going to give material to this definition. That is, what we mean by this, tirikuti, the source point panotangira vector redu, the source point of this vector is always the origin. That is what the source point is. Maybe let us preempt a little before we double down on this definition. We defined a vector as a quantity with what and what? With both direction and size, kana kuti magnitude. This is what a vector is. A quantity with both direction and size. Saka panapa patiri kuti a position vector always originates from the origin. Then we explain this to mean the source point is always from the origin. You should find out a sense of kutanga direction, then also a sense of size. Saka we are going to start with exposing the direction side of a vector. Then teachers will teach about the magnitude or size of the vector, maybe 2 lessons from now. So this is the definition we have. Of course, in mathematics, we understand things through examples. Here we have points. Saka tirikuti the points, kana kuti the position of points. Let us put it this way. Saka the position of points. What are these points? P, Q, na R. Saka ma points at now, they are of course on a Cartesian plane, cannot an XY plane. But in our first lesson, we introduced kuti when we do vectors at advanced level pure mathematics, we are going to consider a third dimension, which we often identify with Z. But for the sake of practice, let us now consider only 2 dimensions. Saka we have 3 points P, Q, R, and these 3 points are going to be relative to the origin. So what are these points relative to the origin? Origin yedu, it's O. We are going to denote these 3 positions relative to the origin O as certainly denoted as, cannot denoted by OP, then what I say an arrow and indicate that this is a vector, OQ and OR, and of course this is going to be respectively. And I'm going to show you what exactly we mean. Saka panapa we have an XY plane. Let me use a different color for illustration. Saka we have an XY plane. This is y, that's x. Tobva tati, let us say in space we have the point P iri panapa, then we have a point R iri pano, then we have a point Q iri panapa. These are just points existing in space. Saka kuisa this xy plane, tikutsvaga a way of defining these points. But when you are defining a point, of course you need an origin, you need a source. Saka we elect kuti source yedu is going to be the origin, o kureva panapa. Saka kana takuda kuziva kuti vector rinobva pana o pa origin richinobata pana p panapa, we put this direction iri kutiudza kuti this is op. Mapaona? Saka this is the position vector op. Kana takuda kuziva the position vector of r, tichabva kuti pa origin tichinobata r, we put an arrow, so the position vector of r ndi or, as put here. Kana takuda kuziva the position vector of q, tichabva pana o, tichinobata q, making oq the position vector. So this is very important. Those are zvinoreva kana tichiti position vector. Kana takuzotaura about a position vector tina x, y, z, the principle is at large going to be the same. But there are certain notes I want you to put down here. Chekutanga, I want you to note kuti o ino iyi yatanyora apa, it represents the origin. But atisogumira ipapo, and this is an important extension, the origin should be a true zero. And kana chiti true zero, trikuti kana tikada kutora the coordinates of this origin, they should be 0, 0. Saka kana tisina true zero, we do not have an origin. And we should remember kuti ma position vectors emanate from the origin. The other thing we want to add, let me write it here. We can denote OQ, OP, and OR as Q, P, R respectively. Kureva kuti, let me respectively. Let me then illustrate what I mean panapa. Saka the origin vector kana kuti the position vector OQ tinogona ngomunyora as tinogona ngoti Q instead of saying OQ. Saka small letter Q, which is usually bold, but it's like redundant to show kuti it's bold. Saka instead of saying OQ, sometimes inongoya iri a small letter q. Then instead of saying OP, it can just be P. And instead of saying OR, it can just be R. That is also a very important vector. Okay, so this is what we have for position vectors. Let us build upon the position vectors, then teachers also kataku illustrator some of the things which are to do with displacement vectors. But before we get to displacement vectors, there is another concept on position vectors which we should look at. Saka, let us describe position vectors. How do we describe position vectors? So when we talk about describing position vectors, chekutanga, we should know that coordinates are used. Do chekutanga. We are going to be using coordinates. Let us have an example panapa. Our example is we have an XY plane. Everything happens on an XY plane. Of course, we can add it to an XYZ plane, but for illustration we are going to use an XY plane. Let us say we have the point A and the coordinates of A the 2 na 6. Let us say we have the point B and the coordinates of B it's 5 and minus 3. This is what we have. So if we want the position vector of A, we know could we start from the origin or to connect origin na A, and this is called OA, like that. We want OB, we connect O to B with a straight line, of course, and this is what OB. We now have position vectors. But how exactly do we name them? So when we want to name them, what we should notice, vectors are written in column form. They are not written in row form. So they are written in column form. The importance of this is, my coordinates are written in row form. So this is what we refer to as the row form, but vectors are written in column form. Saka natakuda kunyora OA uyu tichangoti OA is equal to 2, 6. And patat are written in column form panapa tachifanga kuzowedzera kuti that is x ndiyo anoenda kumusoro, y ouya kuzasi, like that. Saka vector OA anenge ari 2, 6, vector OB anenge ari chi 5 minus 3. That is how we name, that is how we describe position vectors. Saka we have now mathematized what position vectors are. Let us now look at displacement vectors. Saka my displacement vectors, as I said earlier, are just going to be adding upon what we know already when we talk about position vectors. So when we describe displacement vectors, basically this is the opposite of a position vector, but we don't write it like that. Tinoti, these are vectors which do not originate from the origin, which do not start, talking about do not start, which do not start from the origin. What do we mean? Can actually do not start from the origin. Talking about these vectors are a result of joining points in space. Tikangozvinyora zvakadai so hazvina zvazvinoreva unless we dramatize, cannot we show examples of what we mean. So I am going to use the two diagrams which we have already put down, starting with the first one. So you have to allow me panapa, I'm going to take this diagram. This is what we are going to be using. Let us say we have this diagram. Tatoziva already kuti OP, OR na OQ ndio ma position vectors are PR na Q. I want you to note kuti PRQ atanga angori ma points in space. Ndobva tazoshandisa a reference point pataisa this Cartesian plane, XY plane, and we are going to reference from the origin, which is O. But our displacement vector now does not start from the origin, but it results from joining points. So let us say we join these 2 points. Tika joina P na R, like this. Saka toda kuziva what is the displacement vector PR. That is now what we want to learn. Saka different mathematical literature proposes different methods of going about this. But in ini I have what I refer to as a principle, a central thesis, which I always use to be able to define this. Saka kana chida kuziva kuti PR ndiani, central principle yamunofanirwa kushanda nayo inoti, so this is the principle I use, inoti following vectors are equal to the opposing vector. Following vectors are equal to the opposing vector. What do I mean by this? Saka kana chiti following vectors, of course tiri kuguidiwa nema arrowheads aya. Saka tikatarisa pano tichaona kuti OP, vector OP handiti riri kuteverana na PR. Saka tiri kuti OP plus PR, this is equal to, but mukatarisa muchaona kuti OR are in the opposite direction of this flow ya OPPR. Saka OP plus PR doma following vectors, they are equal to OR, which is the opposing vector. So when we do vectors, direction is very important. Kuti OP nekuti PO zvakatosiyana. Understand? Saka you should be careful there. That's PR for us. What if we want to join, let me say, PQ? Truda vector PQ. How are we going to find PQ? Tinotanga taita note the following vectors. Tichaona kuti O na P, its OP is following PQ, which is equal to OQ, which is opposing that general direction. Saka kana takuda kutsvaga kuti PQ ndiani, we are basically going to make PQ subject to formula, so PQ will be equal to OQ minus OP. Murikuona how easy it is. We can also apply the same principle, and I want you to find this on your own. What about kukana tichida RQ? Tinoita say for RQ. So kana tichida RQ, tichatanga tatarisa mavectors ari kuteverana. Toona kuti OR na RQ zviri kuteverana. So OR plus RQ inge iri equal to OQ, which is opposing the general flow. So this is how it is done. This is how we manipulate. This is how we find displacement vectors. But this might not make a lot of sense unless we actually use a real-life example. For our real-life example, we are going to be using this diagram which we have already proposed, but let me clean it up a little. Saka, let us remove this and also remove that. Okay. Saka, let us work on this. Saka panapa, we already know kuti OA anenge equal to X, Y, but in column form, saka 2, 6. And we also know kuti OB anenge equal to 5 minus 3. Let us say question yedu iri kuda kuti titsvage kuti ko AB ndiani. Remember that AB is not a position vector, it is rather a displacement vector. So when we got into physics and science, to displace is generally to change positions. That's why displacement, the other term for displacement is what? Distance. What is a distance? Length between 2 points. Understand? Saka, a displacement is a distance which has direction attached to it. The moment it is a distance, it's a scalar, it has a size, a distance of 10 kilometers, a distance of 10 centimeters. Then if we add direction, it becomes a vector. Then we call it displacement. In simple terms, yatiri kuti displacement ndiyo distance kana tiri kumascala. So we have OA and OB, we need AB. Kuti tiwane AB, we need to find vectors which are following each other. Then we write our equation. Saka OA ari kuteverana na AB, as you can see. And this is equal to OB, which is opposing the general flow. Isusu tikuda AB, saka we make AB subject of formula. So AB will be equal to OB minus OA. Then we are going to replace OB with what? 5 minus 3, subtracting. Then we also replace OA with what? 2, 6. Now this takes us back to my vectors atakaita ku O level. Atinoziva kuti we are going to apply the principle of correspondency. Principle of correspondency inongoti if we have AB, for example adding CD, this is just going to be equal to A plus C, B plus D. It's simply a matrix addition. Saka kana takuda kuziva kuti AB ndiani, maybe I can be allowed to remove this part. To know kuti AB ndiani, tichangoti AB is equal to, then 5 uyo ari kusubtracta 2, because 5 na 2 they correspond, they are joined by this arithmetic operator minus. Then apa tikuti minus 3 minus 6, which is equal to 5 minus 23, then 6, 7, 8, 9, correct up on minus 9, like that. So we are going to later introduce dot product, vector multiplication, scalar multiplication, patingitane scalar multipliers, which is going to tell us that panapa we can actually factor out 3 so that it becomes 1 minus 3, like this. Let us now say kuti takuda kuziva kuti BA ndiani. We now want to learn kuti BA ndiani. Saka the first thing you should appreciate when you are doing vectors, ku appreciate kuti AB na BA they are different. Saka that is the first thing we want to hammer. AB is not equal to BA. But let us prove it mathematically. Kana tikada kutsvaka BA apanda reverse direction, we are going to look for vectors which follow. Saka panapa takona kuti OB iri kuteverana na BA zviri equal to vector iri opposite direction OA. Saka OB ndiani, we come back here. Alright, before we do that, let us make BA subject of formula to make our life easier. Kurot pana penenge yachi OA minus OB. That said, takuti ko iyo OA ndiani, OA ndi 26, subtracting ko OB ndiani, OB ndi 5 minus 3. So this is equal to 2 minus 5, then apa mchaona kuti ndi 6 minus 3, which gives us 2 minus 5 ndi minus 3, and 6 minus 3 zvongoreva kuti 6 plus 3, since panosangana ma minus panoita plus, so 6 plus 3 ndiani ndi 9. Saka this is the answer we get. Now compare these two answers. There's something you are going to notice. What are you going to notice? Muchaona kuti pane a negating effect. Patatsvaga AB pamsoro pana 3, as panapa pana minus 3. Pasas pana minus 9, pano pana 9. Saka this is negating, tango reverse direction. Principle yatinodzidza with all this ndeye kungoti changing signs reverses direction. Saka kana chi reverse direction, zvingoreva tachinja sign. For example, kana tina ab akadai so, tikati ab are equal to xy, zvinoreva kuti kana iri the same vector but this time ava ba anenge angorichi minus x minus y. Mapaona? Saka tikangochinja sign ya 3 to minus 3, sign ya minus 9 to 9, tinenge tato reverse direction. So if we are given ab, we can infer ba from what ab is. That is the beauty of vectors. Okay, so now what we want to do is toda kuita a practical example, kana kuti an examination example, then I'm going to give the class an exercise. So stay tuned. The position vectors of A and B relative to an origin O are 1, 1, 2 and 3, 5, 6 respectively. Saka taudza kuti the position vectors of A and B relative to the origin kureva kuti OA ndiyo inenge irichi 1, 1, 2 and OB ndiyo inenge irichi 3, 5, 6 like that. Saka zvorubva zvazonzi if M is the midpoint of AB, find the position vector of M. Tanyora pasi what OA is and what OB is. Tava taudzwa kuti M is the midpoint of AB. Saka tinenge connector A na B, then the midpoint of AB ndo yatiri kutsvaga. We want to find the position vector of M. Saka kuti tiwane position vector of M, we should appreciate. Panapa we could have put this down on a diagram, but to be honest, a diagram which is in 3D, kureva kuti which has 3 dimensions, x, y, z, it's difficult to work with. Saka we just have to know kuti OM, which is the position vector of the midpoint, is obviously going to be equal to half of OA plus OB. That is what it's going to be equal to. And let me just try to dramatize what is happening. Saka ndisikuda kuisa xyz plane panapa, it's difficult to work with. I'm just going to put the points. Let us say this is point A and this is point B. We know kuti tive ne point A, it's going to come from a certain origin. Let us say this is the origin, or let me put the origin like this. Anditika. Saka from the origin, tichinobata pana A panapa. This is going to be OA. From origin, tichinobata pana B. This is going to be OB. Then tikabatanidza A na B to make AB inenge yadai so. Anditika. That's AB as a vector. Chirikunzi M is the midpoint of AB. Kurot M anengari panapa like that. So kana tichida kuziva kuti what is the position vector of M, zoro tirongobva pa origin takananga panani pana M. Saka in mathematical terms tinofanirwa kuziva kuti uyu ndi A handitika. What are the coordinates of this point? Taona kuti ndi 1, 1, 2 kureva kuti this is actually from an xyz plane. Then pana B panapa taona kuti ndi 3, 5, 6. Saka tikada kushandisa method from coordinate geometry yekutsvaga midpoint, it's going to be difficult because when we were taught that method, we were assuming cannot we were using an xy plane instead of an xyz plane. So half of OA plus OB do inenge iri OM. Okay. So it's important here to just know kuti this half irongotaura kuti M ari kuwanikwa halfway between A na B. Then if we add OA na OB, that is how we are going to find OM. Saka OM inenge iri equal to chi. OM is equal to half of, what is OA? OA ndi 112 plus OB ndi 356. Like this. So I should know correspondence haimbo chinji panapa. OM is now equal to half of 1 plus 3, 1 plus 5, 2 plus 6, which is equal to half of 1 plus 3 in the 4, 1 plus 5 in the 6, 2 plus 6 in the 8. Then at started do scalar multiplication, but you should remember it from your O level. A scalar is going to multiply every term inside the vector. Kurauti panapa inenge basically half of 4, half of 6, and half of 8, which then is half of 4 in the 2, half of 6 in the 3, half of 8 in the 4. Saka 2, 3, 4 is going to be our final answer. Saka yatinenge taita hapo, we are going to add upon it in our next lesson. It's scalar multiplication. So this is how it is done. In our next lesson, we are going to be looking at the arithmetic operations of vectors. And by arithmetic operations, the two concepts we are going to look at are addition and subtraction, which we already introduced in today's lesson, because addition and subtraction ndio inogadzira chi, ndio inogadzira ma displacement vectors. Then we are going to introduce a somewhat new concept, dot kana kuti scalar multiplication, kana kuti panapa toti dot or scalar product, which we have just preempted in today's lesson, but we are going to look in depth in our next lesson. If you find this lesson to be helpful and you want to join our private class, where we have exercises, we have tests, and in truth, in honesty, my lessons are actually tailor-made for my private students. If you want to be part of that group, advanced level pure maths, you can WhatsApp us on +263 71 521 3310. Thank you and take care.